In this session, we will be talking about VPC or Virtual Private Cloud. A virtual private cloud is a service in AWS that lets you launch the AWS resources in a logically isolated virtual network that you define. Thus, in this case, you have the complete control over your virtual environment. That may include the selection of your IP address range, creation of the subnets, configuration of the route tables, and network gateways. We can thus use both IPv4 and IPv6 for most of the resources in our virtual private cloud. This also helps us in securing access, and it makes the access for our resources and applications easier. AWS has few foundational services. AWS Vpc is one of them. The other one are S3, VPC, IAM. Those are the services that we'll be talking about later. As in this session, we are talking about a VPC. Remember that a VPC makes it easy for you to customize your network configuration. So consider this example. You have a public-facing subnets for your web servers that have the access to the internet. Thus, this system can be used for your backend systems, for your databases, or your application server. Remember, by the name private-facing subnet itself, we understand that this does not have a internet access. Now, let's say we are planning to create a web server. In that case, we will create it inside a public subnet. VPC lets us use multiple layers of security, including the security groups, the NACL or the network access control list, thereby helping us to control the EC2 instances inside each subnet. And this is also the premise of what we are going to do in this session. So before we get started, let's have a blueprint of what we are going to do in this session. We'll be creating VPCs. We'll be creating few subnets inside the VPCs. We will be configuring the gateways. We'll be creating the subnet as a public subnet and as a private subnet. We will be installing the database inside the private instances and our machines inside our public instances. So web servers inside the public, database inside the private. Now, if you remember, we said that the database cannot be accessed over the internet because it's on the private subnet. That's also what we are going to do in this lab session. So let's get started. Step one, we have to talk about VPC or Virtual Private Cloud. To open VPC, you can either click on Services and navigate to Networking and Content Delivery, thereby clicking on VPC. Alternatively, you can also go and either type VPC inside the search window, or you can also go and type Virtual Private Cloud, which will basically bring the VPC in front of you. Okay, so I have typed in VPC. I see VPC on the top. I click over there, and as you can see in the address bar itself, it is telling me I'm inside AP South 1, which means Mumbai. I'm inside aws.amazon.com. I'm inside the console of AWS, and the service that I am working on is VPC. Also, the home region happens to be AP South 1, which means Mumbai. So if we go to the right, we'll also see the region over here. My region right now that I have selected is Mumbai. Each one of you, when you are creating your own AWS account, you will be allocated a default region. In general cases, the region happens to be Ohio. However, in case you want to change the region, you can just click on the region, select the new region of your choice, and you can navigate to that region. When we say a home region means the region where I am working most of the times. Let's take an example. My database servers are located in India. My client is located in India, and the people I'm talking to are located in India. In this case, whenever I go and create an instance or a network, it should be created in India. So basically, India becomes my home network. Again, remember, this is a relative term. Let's go back to our VPC. Over here on the top, I see that I already have 2 VPCs, which I had created. Let me go and remove one of them, and we'll go and create the VPC from the scratch. So as you can see, I already have a internet gateway, a security group, and 2 subnets inside the VPC. I'll delete it right now, and we'll start from the beginning, wherein step 1, we create a VPC. To create a VPC, you have 2 options. Either you can go to VPC dashboard and you can click on launch VPC Wizard, in which case AWS has already created 4 options for you. If you want to create it inside a public subnet, a public along with a private subnet with a VPN access, or a private subnet with only a hardware VPN access. You can choose any of them, and if you choose them, it will navigate and it will automatically create the configurations for you. Our job will be to just define the CIDR blocks. So this is one way of doing it. Apart from it, you can go and create the VPC manually. Generally, if you create it manually, you have more configurations which you can support in this case. So that's what we are also going to do over here. So for that, we will click on Your VPCs. We will click on Create VPC, and I will give this VPC a name. Let's call it as Home Region Mumbai. That's the name of my VPC. Next step, I have to choose a CIDR. I am saying 10.0.0/22. Now, if I want, I can have my VPC for IPv6. If I don't want, I can leave it as it is. Right now in this session, I don't need the IPv6, so I'm just leaving it as it is. Next part, you have option of tenancy, which is default, and dedicated. The dedicated one is the network that has been created for you. And thus, in this case, this dedicated tenancy means that all the instances that you launch inside the VPC will run on the hardware that is dedicated for a single customer. So you have a better VPC configuration in this case. So this actually comes in when you go for a dedicated host in case of EC2 that we are going to see once we launch our EC2 instance. So for now, I have chosen my tenancy as default because I want a general VPC. Next, I can add few tags. So let's take a tag, for example, let's say created by, and I'm giving my name. I can also give the date over here. So the tags are generic in nature. It's for you to understand that what this resource in AWS is actually doing. So I have put the date, let's say 03-July-2021. It can be anything. So the reason why we add tags is because when we have to manage the infrastructure and I see multiple resources. So take an example wherein we have hundreds of resources of AWS. So in some time, I will start to forget that what each resource is exactly doing. In that case, a tag comes in handy for me. So for now, I have chosen these 3 tags and I click on Create VPC. It's going to take a few seconds, and once the state becomes available, it means the VPC has been created for you. So over here, you have CIDRs, you have the flow logs, and you have the tags. So once the VPC is done, we will go and create few subnets for ourselves. In our example, we will create a private subnet and a public subnet. So let's do that. For that, click on subnets and then click on create a subnet. So I can choose create subnet here. And this is part of my VPC. Next part, I'll have to give the name of my subnet. Let's call this subnet as a public subnet. I can choose it to be inside any of the AZs or availability zone. So this one, I'm putting it inside 1A. Next step will be to decide the CITR. I am saying 10.0.0.0/24 and create subnet. Once it becomes available, means this subnet is ready to be used. Let's go and create one more subnet, something known as a private subnet. So I click here, I give the name as private-subnet. And next step, I click on my availability zones, wherein I go and select this one in 1B. Now, it's not a rule that you have to make it in 1A or 1B. It depends on your configuration. AWS also gives you an option of no preference, in which case AWS will automatically allocate the AZ or the availability zone for you. However, shortly, we are going to talk about load balancer and the EC2 instances and my configuration, wherein we'll see that this actually will come in handy in those scenarios. So for now, I'm choosing it as 1B and I'm selecting the CITR as 10.0.10/24 and click on create subnet. If everything is good, this should also become green or available. If I remove the filters, I should see my two subnets coming up as a private subnet and a public subnet. Next step is to attach the gateways. Now, inside AWS gateways, I have two options. I have a gateway for IPv4 and I have a gateway for IPv6. A gateway generally means how you are going to communicate with your VPC. So to communicate with the VPC over IPv4, I have something known as a internet gateway. Let's create that. For that, click on internet gateway, click on create internet gateway and give it a name. I am naming it as IGW1 or Internet Gateway 1 and click on create internet gateway. Right now you see the state is detached. The reason for that is you have just created a gateway. You haven't attached it to any VPC. So next step will be to go and attach it to a particular VPC. Now you can either do it from actions and attach to VPC, select the VPC and click on attach internet gateway. Alternatively, you could have also gone to your internet gateway, selected your gateway, click on action, attach to VPC, and you could have selected the VPC there also. So if the gateway has been attached, next step will be to attach the IPv6 gateway or egress only internet gateway. If in case you want the communication to happen via IPv6 also, in that case, you will choose this. For this, click on create egress only internet gateway. You can name it like, let's say EIGW1 or egress internet gateway 1. I am selecting and tagging it to my VPC and click on create egress only internet gateway, which means this gateway has also been created for me. So now I have created a VPC which has two subnets, a private subnet and a public subnet, which is connected to the internet gateway for IPv4 or normal internet gateway. It is also connected to egress only internet gateway, which is for IPv6. Next step is to create my routes, which basically will control the traffic going in and out of my network. For that, I will click on route table and I'll go and create my two own route tables. One, I'll call it as the private RT or private route table, which is for my VPC. And one route table I will create as the public route table. For that, again, we click on create route table and we click on public RT, and this is attached to my VPC here, and I click on create route table. So now I have two route tables. One is a private, one is a public. The public one has to be attached to my gateways, the internet gateway and the egress only internet gateway, because that is how my public route table will actually be connected to the internet, which means any subnet which is connected to my route table will also be connected to my gateways. For that, select the route table, click on routes, click on edit route, then add route, select your gateway, and let's select that. So done. Now, next step will be to select the range from which you want this connectivity to be done. I want it from anywhere in this world over IPv4. For that reason, I select 0000/0. Next step, I also need the egress gateway or EIGW. So for that, we have selected the egress gateway, and I will have to give the address : 0, which means it is connected to the egress only internet gateway. So now I have my route tables, I have my subnets, VPC, and my gateways. Next step will be to attach my gateways to my subnets. So gateways to subnets, if you try to attach, okay, let's try it out first. If you click over here and you click on actions, you will see attach to VPC. You don't even have an option to attach it to subnet, which means you can never go and attach your any networking device to the subnet. What you can do rather is you can attach your devices to your VPC, and via your route table, you can control the traffic which is flowing inside your VPC. And this route table internally is connected to a subnet. So if we go back into our discussion, we have created already a VPC, subnet, route table, gateways. Next step will be to attach my route table to my gateways, which we have done, and finally attaching my route table themselves to the subnets. For that, click on edit subnet association. Right now I am working on the private subnet, so let's confirm it. Yes, that's a private route table. Another way to prove it is you go to routes and you see it is not connected to any gateway, whereas if you click on the public route table, you will see it is connected to the gateway. So let's go back to the private route table. We click on subnet associations, we click on edit subnet associations, and we select the private subnet and click on save associations. If this is done, next step, I will go to my public route table. I'll click on the subnet association, edit subnet association, and select the private subnet and click on save association. Now, any subnet, which is my public subnet in this case, over here will have access to the internet because it is connected to the route, which in turn is connected to the gateway, whereas the private route table will only have the private addresses. So right now we have already created the gateways and our route tables over here. Next step, if we want to go and create an instance which has a static IP address, we can also go and create an elastic IP. For that, I can click on allocate elastic IP addresses and I can click on allocate. Now this IP address has been created for me. Right now it is not attached to anything because we are not using it. In some time when we go and create the instance, we are going to see that this elastic IP can be attached to my instance. Let's call it as public IP -1 -home for now, so that it will become easy for us to understand it. Now we'll go and create the instances, and we will create it inside the VPC and the subnets that we have created earlier. To create an instance, we go to services and we open EC2. So I have opened up EC2 console inside the region of Mumbai. So let's go to instances, and I'll create two instances. One will be a private instance and one will be a public instance. Now, how do I decide whether our instance is a public instance or a private instance? So for a private instance, we should have the instance that does not have a public IP, whereas a public instance will have a public IP. To be specific, we will go and give the instance the public IP that we had created inside our elastic IP. So we already have the IP. We just have to go and create the instance and attach it to the elastic IP that we created over here. So let's go to the instance and click on Launch Instance. I will choose a Ubuntu 20 instance in this case, and I will select a T3A micro instance. Next, configure the instance detail. I will put it inside my VPC, and because this is a public instance, I will go and assign a IP address to it. Next, we have to go and launch the instance. So for that, I will click on Launch Instance, and let's wait for the instance to be launched. To confirm if our instance has launched or not, you can wait until the instance state goes into green and goes into available state. Let me call this instance as a web server. As we see the instance is running right now, we'll go and assign the IP address. So if you see, this indeed has a public IP address. However, this IP address is going to change as soon as the instance stops. Let's go and test it out first. For that, click on Actions, click on Instance State, and click on Stop. Note down the IP address. It was 13.233.206.125. We'll go and stop the instance first of all. And we are going to see that the instance will go into the stopped state, and the IP address is going to change if I go and start the instance again. Let's wait for that to happen. Now that we see the instance is in stopped state, we will go and add the IP address. So if I go and start the start the instance again, for instance, if I click on yes, start over here, you see right now the IP address is not available, but the moment I go and run this instance, I get a new IP address. So we generally don't want the IP address to switch or change at each time. So for that reason, we will go and attach the elastic IP that we had created earlier. For that, click on Elastic IPs, click on Actions, click on Associate Elastic IP Addresses, select the instance that we created, select the private IP, and click on Associate. Now, if we go back to our instance, we are going to see that the IP address of the instance has indeed changed. But now if we go and stop the instance, this IP address won't ever change. The reason for that is this is now attached to our elastic IP, and elastic IP remains the same irrespective of whether the instance is running or it is in stopped state. To confirm that, let's go and stop the instance again. And we will see that the IP address is 13.232.62.49. Let the instance stop. Once it is stopped, we will go and start the instance again, and we'll see the IP address remains the same. Also, please note, now in this case, this happens to be a hyperlink. So it's a clickable object. The reason for that is this is a elastic IP or a public IP, which is associated with that instance. Now that the instance has stopped, if you see, I still have the public IP address over here. If I go and start the instance again, still the instance will have the same IP. So that is the advantage that you have with elastic IPs. Generally, the IP addresses will never change until you go and explicitly detach your instance from the IP address, or you remove the elastic IP address completely. So let's go back, refresh the page, and I see it's into running state, and the IP address happens to be 13.232.62.49. Let's now go and make a connection with this instance so that we can indeed see that I can make a connectivity with this instance. As we have called it as a web server, in this scenario, I will go and install a Apache web server inside this instance. However, before I go and install Apache web server, the Apache web server is going to work on HTTP traffic or port number 80. So for that reason, I will have to go and enable my port number 80 on that instance. For that, I click on security groups, after which I click on inbound rules, then edit inbound rules, add rule, and over here I will go and add my HTTP traffic, and I am saying it is allowed from anywhere. Please note, if you want to access it only from a specific IP, you can choose my IP, or you can choose custom and you can give the IP address from where you want this instance or the security group to be accessed. It can be a specific IP. It can also be a range of IP. It can even be another security group with the configuration that it should be part of the same VPC. So right now I will choose it as anywhere, and I click on save rules, which means that now if I make a connectivity with my instance and my instance happens to have a web server installed, I should see the web server showing up for me. Let's go and test it out. For that, click on the connect button on the top and click on the EC2 instance connect browser-based connection and click on the connect button. If you do this, AWS will open up a new tab for you. This is the same tab where your EC2 instance is working. So I'll just put it on the right so that we can see a few things. The IP address in this case is 10.0.0.237, which is also the IP address in this case. Next, we will go and install the Apache web server inside that. For that, I will just go and run the commands required to install the Apache web server. First command, sudo apt-get update, is to go and get the distribution package and update it. So it can have the security packages, it can have the update packages of the softwares which are installed. So it's always a good to go first and update the packages. Next, I will go and install Apache web server. For that, we will go and type the command sudo apt-get install and Apache 2. The moment I hit that, I will have to go and type in Y to confirm that indeed I want to make a connectivity and I want to install Apache 2 web server inside my instance. Once this is done, I can choose to close it. Now, if I go and have a look at my IP address, I will see that I have the web server coming up. So indeed, I have created an instance inside a public IP, and this public IP is connected to the internet. Now, because we want to see multiple instances, what actually happens in real time is you have multiple instances which are connected via a load balancer, which in turn is part of your network That's how it actually works. So that's what we are going to do. So for right now, we'll go and create one more public web server. So right now I am renaming it to web server -1. I will go and launch another web server, which I will name it as web server -2. For that, let's go and select the instance. Let's say T3A micro again. Next, configure instance detail. I am selecting my VPC. I am selecting my public subnet. I am choosing the IP address. Then in this step, I will directly go and add my port number 80 while creating my instance itself. So I don't have to go and do the additional step of going to the security group and adding port number 80. If everything is good, just click on launch instance over here. And I see that indeed I have an instance coming up over here. I'll just go and rename it to web server -2. Remember, both of them are part of the same VPC and the same subnet. To confirm that, you can have a look at the VPC ID over here and the subnet ID for 2 and the VPC ID and subnet ID for 1, which is indeed the same. So let's go and make a connection with it. For that, we click on the connect button, the browser-based connectivity. We click on connect again, and we will follow the same step which we did last time to install the web server. For that, first we update the distribution by sudo apt-get space update. And once that is done, we go and type in sudo apt-get install Apache 2 to install Apache web server. For that, sudo apt-get install and Apache 2 and just press the Y. And indeed, Apache web server should be installed inside my instance. If everything is done, let's go back and open this IP address. If I open this IP address, I am going to see that Apache 2 web server is again installed inside the instance. So actually, I have two instances now, web server 1, web server 2, which are connected to my public subnet, which in turn is connected to my public route table, which in turn is connected to my internet gateway and egress only internet gateway, which in turn is connected to my VPC. So if I have to tell about how am I making a connectivity with my instance, the answer is from my local IP address at my house right now, it goes to AWS data center in Mumbai, from where it goes inside my VPC, from where it goes inside my gateways, and if my route table allows, it goes to my subnet, and eventually it goes to my instance. And that's how I am making a connectivity with my instances. Let's proceed. Right now, we have created two web servers over here, but we'll also go and add a load balancer on top of it, because a web server should ideally have a load balancer to balance the load. For that, I click on a create load balancer. Now, because this is a web server or a HTTP web server, I will choose the application load balancer in this case. I will click on create. I will give it a name. Let's call it as web site. Next, I will have to choose my load balancer instances, which is HTTP over port number 80. Next step is to select your VPC. Now, if you remember, we had told and talked about the VPC, that a VPC is important for a load balancer also. And this indeed is the reason why we said that. So I'll go and choose my VPC, and I will choose the subnets which are present inside my VPC. Next step, I will choose the configuration settings, the security group. I can choose any one of them, but we will have to remember that this should allow port number 80. So let's call it as VPC-Mumbai-load balancer. And we will go and add port number 80, which is already there. So next step, we click on routing, and I will have to create a target group. So for target group is nothing but a collection of the instances. So for that, I just named it. In the next step, I will go and add both my instances to my target group. Finally, I click on review and create. Now, if this is done, in some time, I click on my DNS and I hit here, I will be forwarded to my instance, which in turn is going to forward me to my web servers. Right now, it is into provisioning state. Let's wait over here until it goes into the state from where I can view my load balancer. Let's go and refresh the state and we see that it goes into active state. Now, if we go and click on the DNS and we open the address, I should see my website coming up, which should be for instance 1 or instance 2. Please remember that you'll also have to go and update the security group so that it allows the connectivity to port number 80 where my servers were working. So for that, we click on inbound rules again, and we see that port number 80 is enabled, which in turn means that my load balancer that we created should be connected to the instance, which in turn have the Apache web servers running in them. So now that the DNS is up, my state is active, my type is set to application, and it's an internet facing load balancer. Let's go and have a look at the DNS name. I hit this, enter, and I indeed see that my web server is up and running, which means my load balancer, which is connected to my VPC, which in turn is connected to my gateways, and it's a public facing network. So this is how the basic configurations are done once we work in AWS, wherein we create the private subnets and the public subnets, and the private and the public instances. Now that we have created the public instances, let's also go and create a private instance to see how does it work and what are the differences between the public and the private instance. For that, I'll again go and choose launch instance. I'll select Ubuntu Server 20. I will select a instance type, let's say a T3A micro. Next step, I will select the VPC like we did last time. I'll click on subnets, create a private network or a private subnet, and launch the machine. Now, if you have seen, I did not add any security group to this because this instance happens to be a private instance, and a private instance should have no connectivity for any port number. Now, in certain scenarios, you might want to enable that. Let's take example of a database. If you're working on MongoDB or Cassandra or MySQL or Oracle or MS SQL, in that case, you might want to go and open those specific ports for the specific IP addresses. Going back, if I go to my instance now, you will start to see a difference between the three instances that we created. So let's go and have a look at it. If you see, my web server 1 has a public IP, my web server 2 has a public IP, whereas the private server does not have a public IP. And this indeed is the difference between a public and a private instance. A public instance will never have a public IP. This is what we talked about in the beginning of the session, where we talked about the private instances and the public instances. Now that we have seen how the instances work, let's go and terminate the instances. For that, you can choose the instances, click on Actions, Instance State, and terminate the addresses. You might also want to go and release the IP addresses because if IP addresses are not connected to an instance, which are in turn in stopped state. So let's say I have a elastic IP which is connected to an instance which is in running state. In that case, I won't be charged for the elastic IP. However, if I am connected to an instance which is in turn connected to an elastic IP, and that instance is either in stopped or in terminated state, in that case, AWS will charge me for the elastic IP address. So let's wait for the instance to be terminated. Now that it is being terminated, I can also go and delete my load balancer that we had created. For that, select the load balancer, click on Yes, Delete, and your load balancer has been deleted. Let's go back to our instances, and we see all the instances are actually terminated. Let's go to our elastic IP, and I see I don't have any elastic IP over here. The reason is present in front of you. It says that the elastic IP that was associated with the instance has been deleted because the instance got deleted. For that reason, the elastic IP was also deleted or revoked. Let's go back to our VPC. And if we refresh our VPC, we see I still have my public subnet and the private subnet. I have my VPCs, route tables, internet gateway, and egress only internet gateway. Now let's go back to our NAT gateways. So for that, a NAT gateway is used for the instances or for the networks that have the private IPs. So to understand this, let's understand it via an example. I have my database server And this database server is in turn over the private IP. Let's say I want to make a change or a update on my instance. I want to change my database version, or maybe I want to go and update my operating system, or maybe I want to just go and upgrade or downgrade the database version inside my instance. Now, the instance happens to be a private instance, which means it doesn't have a public IP, and the updates are generally done on the public IPs. So how do I update an instance over the internet that does not have a public IP? The answer is my NAT gateway. So a NAT gateway is or a gateway for the private instances is a network address translation service, which means you can connect the instance inside a private subnet and you can connect it outside your VPC. Remember, the services inside your VPC can initiate a connectivity with the external services. However, the external services cannot initiate a connection with these instances, which are the private instances. Now, whenever you create a NAT gateway, you will have to think about two things and the two connectivity type. First is the public, second is the private. The public one can be connected to the internet through the public gateway, whereas the private can be connected to another VPC or on other on-premise network. Also, a NAT gateway has an hourly usage and data processing rate. So let's go and see how a NAT gateway is created. For that, we will go to NAT Gateways. We will click on Create NAT Gateway. I will give it a name. Let's call it as NAT-Gateway-Mumbai. Next step, I will have to choose a subnet. If you have been following me, you would have listened that I told that this instance should be connected to a private instance or a private subnet. So for a NAT gateway, I will choose my private subnet over here. And if I want, I can make it private, like we said that it cannot connect to the internet, or I can make it public. Now, if I have Elastic IP, I can choose that Elastic IP over here. If I don't have, I can just click on Allocate Elastic IP address, and I can click on Create NAT Gateway, which in turn means my NAT gateway will be created. Next step will be to go and add it to my route table. So a NAT gateway or a gateway has been created, but until we go and do the entry inside the gateway is actually as good as not being present. So you will have to go and do the corresponding entry inside the route table also. For that, we click on route tables over here. We select my private route table. I select my routes. I click on edit routes, then add routes. Here I'll go and select my NAT gateway and select my NAT gateway over here. Here I will choose my IP address from where I want the connectivity to be enabled. Now, in general scenario, it should ideally be the IP address of your organization or for your place where you are. This is my IP address. So for that reason, I go put /32 and click on Save Changes. And my NAT gateway has been added to my route table, which in turn means it has been added to my private subnet. Thus, any instance which is part of my private subnet now can access the internet through the NAT gateway through the Elastic IP that I created. This is how we work with a NAT gateway. Now, to delete a NAT gateway, you can select the NAT gateway, click on Actions, click on Delete NAT gateway, and delete. Remember, a NAT gateway takes time in deletion, and after deletion again, you will have to go and release the Elastic IP address, or else your IP address will be chargeable. So for that reason, let's wait for the NAT gateway to be deleted, after which we'll go and release the Elastic IP. If you try to do it before the NAT gateway is deleted, it will give you an error that you don't have the access. So let's say I am trying to do it, it says that it doesn't exist. So first of all, you will have to go and wait for the NAT gateway to be deleted. Only after that you can go and release the elastic IP. So let's wait for the NAT gateway to be deleted first. So let's go and refresh, wherein I see that my NAT gateway has been deleted. So now I can go to my elastic IP and I can refresh it once and then click on actions and disassociate elastic IP. Once that is done, you can go back and release it. Remember, this might take some time. So if you see last time disassociated was available, it is not. So this actually happens. So if in case it happens, you just have to go back and click on release elastic IP address, or else you can alternatively wait for 5 to 10 minutes, in which case you can go and then release the IP address. The only thing to notice in this case, you will be charged for those 5 to 10 minutes for the elastic IP, which is added to the NAT gateway, which is no longer into existence. So we have seen and talked about the gateways and the VPC. Let's go and talk about the security now. So security, as we have already seen in case of the instances, if I want a specific IP address to be allowed inside my instance or inside my gateway, I can go and add this to my security group. The same way as we had done this inside our instance, and I created my web server with Apache web server, and I went and enabled port number 80. Next step, I went and I tried to connect with my instance on port number 80, and I indeed see my Apache web server over there. So a security group generally allows any connectivity which is incoming or outgoing to your network. This can be added to your load balancers. This can be added to your instances. So security group in general are a generic thing which is present inside your VPC. Remember, a security group is managed by a VPC, which means only an instance or a resource or a network interface which is connected to your network can access that particular security group. To create a security group, you can click on security groups and click on create security group. Next step, you will have to give it a name. So let's call it testing hyphen security group -1. Here you can give a description, let's say web server. Then you will have to choose your VPC. I have chosen my VPC. Now let's say you want to allow any inbound or outbound rule, you can do that. Let's say if I were working on a website, I would have allowed my HTTP and HTTPS traffic from anywhere. In that case, I select HTTP, then I select HTTPS, and both the things from anywhere. In general, outbound rules are all the traffic is allowed. So you only make the checks inside the inbound traffic. Outbound traffic, generally everything is allowed. However, you might want to change it if in case you have a specific scenario. For instance, I want only HTTP and HTTPS traffic to incoming and outgoing rules. For that, I can again go and select my HTTP in case of outbound and HTTPS again. So here and this one, and I select it as anywhere and anywhere. And I click on create security group. Doing this is going to create a security group for me. This SG hyphen happens to be the security group ID, and this is the name of the security group. So I now have a security group, and this security group can be used by any of the instances or the load balancers inside my VPC. Next step, I can also go and create a network ACL or a NACL. Please note, NACL by default has been created for you for each of the subnets, which wherever it was. So I created one VPC with 2 subnets. So that is what it is telling me, that the NACL is already there. And this is also the default subnet. Default subnet because this was already present when I created my VPC or my network. If you want to go and create your own NACL, you can do that by clicking on Create Network NACL, selecting your VPC, and give it a name. If you do this, a NACL is created which can be used. A security group can only allow the traffic inside or outside the network. It cannot block anything. If in case you need to A, allow, and B, block the network connectivity to your network, in that case, you can take help of your NACL or Network Access Control List in VPC. Unlike your security group, a NACL can both allow and block the connectivity to your network. So a NACL or a network access control list, it's an optional layer for security of your VPC. It acts as the firewall for controlling the traffic in and out of one or more subnets. You can set up a NACL similar to your security group if you want. In general, that is also how it works. So let's say I have a NACL, so I can use that, or if in case I want, I can go and create a new NACL. So let's try that. I click on network ACL, and over here, I call it as a private-NACL and create. Here, select the VPC and click on create network ACL. Once it is done, let's go back and have a look at the NACL. I see my private NACL has been created. Now, let's say there is a specific requirement where I want to block all the traffic coming on port number 80. In that case, I can go choose edit inbound rule, add new rule. Let's say I can make a rule number by the name of 100, and I am saying that I want to block all the HTTP traffic coming in. So I click on deny over here. I click on save changes. Now, essentially what it means is all the traffic is denied and my port number 80 is also denied. The thing that we wanted to do was to go and disable only port number 80. For that reason, I will click on edit inbound rule. I'll add a new rule. Let's call this rule as 100. This rule will rename it to 90, and I will say all the traffic is allowed. And if I click on save change now, in this case, I will go and create a NACL for me. Now, in certain scenarios, it might say that the rule is already in use. In that case, you can choose a number that is not there. For instance, I chose 110 over there. Now, if you go and refresh the page, it ideally works out always. So what happens is rule number 110 says allow all the traffic. Rule number 80 says block port number 80. If you combine both of them, the end result is allow everything except port number 80. Now, this rule can be allowed to your inbound rule and to your outbound rule. So if you have to apply it to both, you will have to go manually, click on edit outbound rule, and you will have to go and make the changes here also. Finally, if you want to add it to a subnet, you can click on subnet associations. For instance, click here and just select the subnet on which you want this NACL to be applied. For instance, I have chosen my private subnet and I click on save changes. Now, if you see, my NACL is added to my subnet, private subnet, and it will only allow port number 80 to be incoming, and rest all the traffic will be blocked, or vice versa, based on whatever conditions you have made inside your inbound and outbound rules inside your NACL. This is about the security part of VPC. Now there might be a scenario in which you want to make a connectivity of the VPC of AWS with your in-house data center. So let's say you have your own data center, or the customer has their own data center and you want to make a connectivity with them. For that, we use the help of our VPN or virtual private network. In which case, we'll have to go and create the gateways, one gateway at our end, one gateway at AWS end, then we'll have to make a connectivity with them. If this all is done, you will have made a connectivity of AWS with your own data center. To start it, first step is to go and create a customer gateway. Remember, this gateway is at our end. For that, click on create customer gateway, give it a name. Let's say I'll call it customer-gateway-1. It can either be dynamic or it can be static. Next step is to give the IP address. I'll go and choose the IP address for myself, which is here. And if I want, I can also go and give it a name over here. So whatever name you want to say. So I can say like my-data-center1 and click on create customer gateway. Once the customer gateway has been created, it will come up with a unique ID, CGW, or the customer gateway, hyphen the unique ID for that gateway. Once the customer gateway has been created, you will go and create the gateway at AWS end. This is known as the VPG, or the virtual private gateway. So for that, click on create virtual private gateway, give it a name. Let's call it as AWS-gateway-1 and click on create virtual private gateway. This step might take some time, so let's wait for it. Once you see it's into that state, this, by the way, is the same way how we did in case of our internet gateway. So I'll have to select that, click on actions, click on attach to VPC, and I will have to select my VPC and click on yes, attach. It might take some time in attaching, and that's fine. Let's wait for it to attach. Now that we see my customer gateway is available as well as my virtual private gateway is available, I'll go and make a connectivity by clicking on site-to-site VPN connection, then click on create VPN connection, name it, let's say data center to AWS. You will have to select your virtual private gateway and the customer gateway that you created and click on create a VPN connection. The VPN connection should be created in some time, and this means that you have indeed connected your data center to AWS. Remember one thing, that whenever you create a gateway, for example, the virtual private gateway, this again has to go and it has to be added to your route table. So let's say I'm choosing my public or private route table, whichever you want, you can choose, or either both of them if in case it's required. Then click on routes, click on edit routes, click on add route. Here you will select the gateway. So my gateway was my virtual private gateway. This, I select my gateway and I can give my IP address. Basically, it means that I can make a connectivity with my network. Now, if you see, it says that it gives the error, and the error is that this is already being used. The reason is I have attached it to a NAT gateway also, but the NAT gateway doesn't exist as of now. So for that reason, I will choose remove. I will click on save change and I will see my route table has been created. So this is how you go and work with your AWS VPC. In this session, we have seen how to create a VPC, how to create multiple subnets. We created the instances. We added the load balancers to those instances. We gave the IP addresses to those instances. And then we made a connectivity with the instance. We saw that the public instances had a public IP, which means that if I try to open that instance, I saw an actual web server page coming up. Also remember the web server page or the web server we had installed inside the instance, it didn't come up automatically. Next, we created the private instance and we saw that it does not have a public IP. So there is no way by which I can make a connectivity with that instance over the public IP. Finally, we talked about the gateways, which are the internet gateways, the egress gateways, the route tables, the NAT gateways. And finally, when we had to talk about our own gateways, the customer gateways, the virtual private gateways, the site-to-site VPN connection, and so on. Once the connectivity has been done, you can choose to delete the gateways or the connectivity. In my case, I have deleted the site-to-site VPN connection. Then inside the virtual private gateway, I can choose to detach it and eventually go and delete it. Finally, I go to my customer gateway, and this also I can choose to delete my customer gateway. So basically, whatever gateways I created have been deleted, and that's how you generally work with a VPC inside AWS. In the next session, we'll be talking about the network peering, or basically how do I connect my multiple networks with one another. That is the topic for peering connection, and that we'll be doing in the next one. So I'll be seeing you in the next session.